Welcome to our sentiment analysis demo. Let's imagine for a moment that the algo trading company, FinCentX, wants to create a machine learning model that can predict future financial indicators, such as changes in stock value, based on historical news feeds. In the FAME EU project, IBM Research is enabling this capability as an independent, tradable technology component that can be integrated with any machine learning model to explain its sentiment classification. What is sentiment analysis? Let's start with a definition. Sentiment analysis, or opinion mining, is a natural language processing technique used to determine whether data is positive, negative, or neutral. Sentiment analysis is often performed on textual data to help businesses monitor brand and product sentiment and customer feedback and understand customer needs. In financial forecasting, sentiment analysis is a valuable tool that can be used to analyze market atmosphere and predict stock market trends. Our objective in FAME is to replace the original news feed input with a sentiment feed to reduce its size without compromising accuracy. Each sentiment is accompanied by a sufficient subset of the terms in the original narrative that most prominently justify it. How do we achieve this? Our approach leverages large language model technology, or LLM, to find the set of sufficient terms that explains the original news narrative sentiment, and then use that set to enrich the input to the machine learning model. IBM has extended the SAX4BPM library as part of the FAME EU project to cope with text input. We've also developed a machine learning model agnostic service for the explainability of a single input narrative and its corresponding sentiment, as determined by the machine learning model. Our service leverages large language models, such as ChatGPT, for the generated explanations. This is the general architecture of our solution in the overall FAME landscape. As can be seen here, the project is setting up a marketplace platform with the ability to trade and integrate different types of assets, such as data, models, and services. In our case, we're zooming in on enabling an explainability component that can be integrated with any sentiment classification model to provide an explanation for its prediction, while remaining independent of its functionality from the classification model itself. The core idea of our algorithm is to employ the LLM as a zero-shot XAI model to determine which are the case-sufficient terms corresponding to the sentiment that was determined by the machine learning model. We instruct the LLM to provide a list of top K relevant words in the given input narrative that are related to the predicted sentiment. We then present a masked narrative with only the top K terms as input to the machine learning model and invoke it to get the sentiment that corresponds to these terms. If the newly derived sentiment matches the original predicted sentiment, we return the top K terms as the explanation and stop the process. Otherwise, and as long as a given number of threshold attempts has not been exceeded, we extend the prompt to associate the relevant top K keywords with the new sentiment and repeat the process again. In this video, we demo the novel developed service to derive the sufficient set of terms that explains the sentiment attributed to the original input, as shown in this process. We start by importing a text narrative using the UI. In this demo, we use financial narratives provided by one of the project's use cases. After importing the input, we select a sentiment analysis machine learning model to which we are connected via a Docker pipeline and run it in the background. In this example, we input a positive narrative, then select the Vader machine learning model for sentiment analysis that is running in the Docker pipeline. Vader is a rule-based unsupervised learning algorithm widely used in sentiment analysis. After we get the sentiment predicted by Vader, we run GPT 3.5 Turbo to get the top K words in the narrative that explain the produced sentiment. We repeat this step iteratively a limited number of times and select the set of most frequent terms that most significantly explain the original narrative. In our case, these words are well, momentum, attractive valued, and attractive valuation. That's it for our demo. Thanks so much for watching.